สวัสดีครับ Good morning. I would like to talk about hair cloning, a key for alopecia. My name is Associated Professor Rattapon Thaungtong from Bangkok, Thailand. What is the lock door? The lock door in dermatology and alopecia is like a scaling alopecia that hard to treat and androgenetic alopecia that have like a large area or limited donor supply. How can I use stem cell to help? We know that embryonic stem cell and somatic stem cell can differentiate it into many cells. If we compare embryonic stem cell is like a cell on top of the mountain. It can differentiate it into endoderm, mesoderm, or ectoderm. But somatic stem cell can differentiate it into each cell line, like each endoderm, mesoderm, or ectoderm. For cloning, what is a cloning? Cloning is a producing organism with identical DNA, like a dolly sheep. We have two names for cloning. First is reproductive cloning and therapeutic cloning. For reproductive cloning, we clone cell and put it into the surrogate mother. Like in Scotland in 1996, we cloning the sheep. From the black sheep, we separate the nucleus, and the white sheep, we separate the cytoplasm, and we fuse together, use my electrical shock, and then we get the cell, embryonic cell, and then we put into the surrogate mother sheep, and then we got the clone cell, clone sheep here. For therapeutic cloning, we clone the cell and we do the tissue culture in order to differentiate into like a neuron, hepatocyte, renal cell, cardiomyocyte, pancreatic cell, or hematopoietic cell. For hair, how can I use? In embryonic stem cell, we clone, we will get many embryo, and then many men, and then we got it. And if we pick up just only hair, it and destroy, it should have some ethic problem. So if we can use the somatic stem cell, we hope that if we separate the hair from here and then transplant it, or we culture first and then transplant it to the budding area, it should be good. This is a picture that we do FUT or follicular unit transplantation, and this is a concept that we get the cell like an epithelial stem cell or mesenchymal stem cell, and we co-culture together and let it produce the hair follicle and re-implant it into the budding area. It should be good. This is the picture how we create the epidermal cell and combine with dermal cell and let it to produce the hair follicle. This is in the mouse model. This is a schematic representation of hair follicle formation. Use the dissociated cell, inject into the mouse dermis, and let it form the hair follicle. This is a picture, the native morphogenetic pathway, how to create the hair follicle, and this is the picture how we can co-culture and inject the dissociated cell and let it form the hair follicle. In 2008, Intercytec tried to culture the cell and then put into the budding area. And in Dr. Feischl tried to co-culture dermal papillary cell and keratinocyte and form the proto-hair and try to mimic the hair follicle morphogenetic. This is the picture how they inject into the patient. In 2010, Adran tried to do the cell isolation into epidermal cell and dermal cell and do multiplication and reimplant into the patient. But in 2018, they used the tissue engineering using a biomimetic developmental approach. They used the mold and put the cell like a keratinocyte, dermal papillary cell in the bottom, keratinocyte, and this is with the surrounding fibroblast, and let form the hair follicle. This is a concept how to do isolation, the epithelial cell and mesenchymal cell, and differentiate it and use bioengineering to create the hair follicle. Next is the new method that just emerged, is called the iPS cell. iPS cell is different from embryonic stem cell. iPS cell discovered by Dr. Shinya Yamanaka in 2006. They tried to create the induced pluripotent stem cell from human somatic stem cell, and the reprogramming with the 4-factor here, and it turned to human iPS cell. And this human iPS cell can differentiate it to mesoderm, endoderm, and ectoderm. They hope that it can differentiate it into the hematopoietic cell, cardiomyocyte, neural cell, or hepatocyte that can help people in the future. In 2016, they used bioengineering 3D integumentary organ system for iPS cell. They produced, we call the embryonic body from the iPS cell, and then we inject with this here, and let's inject into the skid mouse, and then it can found that it can produce the hair follicle here. This is a picture how they do. In Thailand in 2019, my team tried to do iPS cell using scalp fibroblast. We separated from the, this is a picture, we try to get fibroblast from the scalp patient that come to do the strip harvesting follicular unit transplantation, and then we try to reprogramming it, use this regimen, and then we separate the fibroblast and then reprogramming here, and we got the iPS cell. We confirm by use immunofluorescence technique to confirm. And then in 2020, we try to generate the dermal papillary cell by we continue using the iPS cell, and then we differentiated, use differentiation medium, and let it turn into the neural crest cell, and then after we use dermal papillary medium to turn it into the dermal papillary cell. This is a picture. First, iPS cell induced to a neural crest cell and dermal papillary cell later. This is a schematic in summary. We use around 3 weeks to differentiate it from iPS cell to dermal papillary cell. Today, I talk about the stem cell. We talk about the cloning. We just talk about the technique how to do in some literature, how to use like an iPS cell to do hair follicle from induce the iPS cell and then iPS cell into the dermal papillary cell. We hope that in the near future we can do the hair neogenesis by use scar to induce into iPS cell and turn to dermal papillary cell, and then use the bioengineering method to like a 3D mold, 3D printing, or robotic assist to do hair neogenesis.